Somewhere in the universe right now, physics allows for an ending that requires no warning at all. Not billions of years of stars slowly fading. Not a gradual collapse you could see coming. An ending that could, in principle, happen this instant, expanding outward at the speed of light, rewriting the fundamental laws of physics as it goes, with nothing arriving before it to warn anyone it's coming. In April 2026, for the first time, physicists built a machine that recreates exactly how that ending would unfold. The theory is called false vacuum decay, and it starts with a strange feature of quantum field theory, our most accurate framework for understanding reality at the smallest scales. Empty space isn't actually empty. What looks like nothing is really the lowest measurable energy state of a quantum field stretching across the entire universe. Here's the unsettling part. That state doesn't have to be the lowest possible energy state. It only has to be low enough to seem stable, the way a ball resting in a shallow dip on a hillside looks settled, even though a much deeper valley might sit just beyond the next ridge. Physicists call our current state, if this theory is correct, a false vacuum, stable enough to have lasted 13.8 billion years, but not necessarily the true lowest energy ground state the universe could eventually settle into. If a small region ever tunnels into that deeper, truer vacuum state, a quantum process that appears random and requires no external physical cause to set it off, it would form what physicists call a bubble. And that bubble would not stay small. It would expand outward in every direction at the speed of light itself, and inside it, the fundamental constants of physics, the very rules governing how particles, forces, and atoms behave, would be different. Atoms as we know them likely could not exist inside it. Because the bubble travels at light speed, nothing could ever detect it approaching before it arrived. There would be no telescope alert, no warning signal, no final moment of awareness. Reality as we currently measure it would simply be rewritten, instantly. This isn't some fringe idea circulating on the internet. It's built on real calculations involving the Higgs field, the same field responsible for giving fundamental particles their mass, which physicists have found may itself sit in exactly this kind of metastable state. Careful calculations of how long our current vacuum should last before decaying put the number at roughly 10 to the power of 139 years, a timescale so incomprehensibly long that even the heat death of every star in the universe would be a footnote by comparison. So to be clear, before you close this video in a panic, there is currently no evidence suggesting this is imminent, and every serious calculation suggests an almost unfathomable amount of time remains before it could ever occur. What changed in April 2026 wasn't a prediction about when this might happen. It was proof that the underlying physics behaves exactly the way theorists always claimed it would. A team at Tsinghua University in Beijing, led by physicist Yu-Xin Chao, built a tabletop experiment using a ring of individually trapped atoms, precisely controlled with lasers to mimic the mathematical structure of a quantum field capable of existing in two different energy states, one representing a false vacuum, one representing a true vacuum. By carefully tuning the system, the team watched the ring transition from the higher energy state to the lower one, forming and expanding exactly the kind of bubble that theory predicts would occur on a cosmic scale, captured for the first time as a controlled, measurable laboratory event. This doesn't create any actual risk. Nothing about a small ring of atoms in a lab in Beijing threatens the universe outside it. What it does is something quieter, but genuinely significant. It confirms, empirically, that the mathematics describing one of the most extreme theoretical endings ever proposed behaves exactly as predicted, bridging quantum field theory and the physics of the vacuum in a way that had only existed on paper until now. It also places this particular idea in an interesting position compared to everything else you've heard on this channel. The Big Crunch, the Big Freeze, the timescape model, all describe outcomes unfolding over billions of years, driven by forces we can observe and measure directly today. False vacuum decay is different. It describes a transition that could, according to the mathematics, occur at any point along an almost unimaginably long timeline. And now, for the first time, it's the only one of these models that has actually been recreated, even if only as a small, careful analog inside a laboratory. What all of this really reveals is how much of the physical universe's future remains genuinely open to study, mapped through careful mathematics and increasingly clever experiments. And it's worth remembering that these are models of the physical world as we can measure it, not answers to where all of this is ultimately heading. The true and final end of all things remains something no equation or laboratory experiment can ever fully capture. What do you think? Does knowing an ending like this is even theoretically possible change how you think about the universe? Or does the sheer scale of the timeline make it feel completely irrelevant? Let me know in the comments. Subscribe, because next time we are finally covering quark stars, a theoretical object even denser and stranger than a neutron star, made of matter crushed so violently that neutrons themselves are believed to break apart entirely.